like something. That's what energy. Very gas. And it's then. Yes, I can tell you. That's why. No, oh, yeah, not exactly. Yeah.
He's not here, no.
Okay, page 24. Okay, so we're going to complete the square, very much like how we did with circles and ellipses. What makes this more difficult is having to keep track of the negative in front of either the x squared or the y squared. But first of all, because you're dealing with a quiz that is over ellipses and hyperbolas, you may not be told what shape it is given the general equation. So here's a way that you can tell is that your x squared and your y squared have different signs. Okay, so that's it. If your x squared and y squared have different signs, you know it's going to be a hyperbola. If your x squared and y squared have the same signs, then you know it's going to be an ellipse. But let me, I'll put an asterisk next to that statement because it could also be a circle as well. But you won't have to graph the circle, but you will have to be able to recognize it. But right now, I want you to look at the sign. Look at the signs of x squared and y squared and you can tell that this is definitely going to be hyperbola. Okay, so hyperbolas, we know that ultimately we want our positive term to come first. So we know already how what direction we're moving towards, right? We know we're moving towards this horizontal transverse axis because we want the x squared to be positive. Okay, so we're going to organize it in this form. I want the x squared together first, then the y squared. Then the y's together, and then the constant on the other side. So we're kind of moving towards where we want to go, right? But we want to start setting things up. Right? Okay, so we do want to complete the square for both the x and the y's because both the x and y's are showing degree 2 and degree 1. Is there a GCF that we need to worry about with the x's? No, that's fine, right? Because really, to complete the square, we just want the x squared and y squared to be by themselves without any coefficient. The x squared is fine, so we can move forward. Give me 1 second here. Okay, so that one is going to be nicely set up like that. X squared plus 6x plus space. Now, what GCF do we have to worry about with the y's? -4, that's right. We want a -4 to come out because we want the y squared to be nice and positive in the parentheses. So now we're dividing everything by -4. So what's next? Good, plus 2y. Plus 2y plus space. Okay, if you can set this up, then pretty much this will feel like an ellipse from here on out because you're going to go through the same process as before. Okay, any questions so far?
The y area will be different in the x area.
Not necessarily. It's possible to have 4x squared minus 4y squared. What's going to differentiate this from ellipse is the fact that your x squared and your y squared have different signs. That's all it's going to require for you to know it's going to be a hyperbola. Okay.
It won't specifically say that on the quiz, it's just gonna figure it out.
Yeah, exactly. It may not stay on the quiz. You have to be able to recognize what shape you're dealing with. Okay, so b over 2 squared, what goes in this space? 6 over 2 is 3, 3 squared is 9, so 9 goes here. Any adjustment? Is this going to be 9 as well? Yeah. Yes, so there's no parentheses to worry about, so we can write the same number. Okay, b over 2 squared, what goes in here? 1, right? 2 over 2 is 1, 1 squared is 1. Now 1 goes here, but what goes in this space? Good, because you have to multiply by that -4 in front. Okay, let's factor. Multiplies to be 9, adds it to be 6, 3 and 3. Multiplies to be 1, adds it to be 2. It's 1 and 1. I get 20 minus 4 is 16. Okay, the hyperbola is going to be similar to in the ellipse because we want a 1 to show up on the right side. So if I want a 1 to show up on the right side, what do we need to do? Divide everything by what? 16. Okay, so now we can move into standard form. Okay, just for review, let's go ahead and fill out this entire information and the chart. But then when we get to 4 and 5, let's just focus on getting from general form to standard form. And then that way we can kind of move ahead. But just for review purposes, let's see if we can recall all of our steps here. How is my hyperbola going to open? Left and right, yeah. My x is first, so ultimately I know that my graph will look like this. Center here, vertex here, vertex. Co-vertices above and below. You'll draw a box. You'll draw an x.
Focus for the both
What's on
both sides are on the outside.
On the outside, right?
It's the opposite from the.
Yeah, that's right. That's right. But you shouldn't have to worry about that because your formula will always get you to a c value that's either larger or smaller, right? Because your formula for c squared for ellipsis is c squared equals a squared minus b squared. But your c squared formula for hyperbolas is a squared plus b squared. So it'll just naturally end up further out without you having to make any adjustment. Remember, A is always first because you're always going to write it with the positive term coming first. Okay, you're gonna draw a rectangular box that's gonna hit your co-vertices and your vertices. Highlight your corners. And draw a dotted line that goes from corner to corner. My slope of my asymptote, start from the center and move to the upper corner, up to over 4. Up to over 4, that reduces to be 1/2. Put a plus or minus in front of it, because that will take care of both of your asymptotes. Any questions there? Okay, number 4, how can you tell that this is a hyperbola and not something else?
The signs are different.
Signs are different, yeah, x squared and y squared. Now, if x squared and y squared are on different sides of the equation, you want to bring it all over to one side of the equation before you make that conclusion, right? So you want x squared and y squared to be different signs on the same side of the equation, right? So if they're different sides to begin with, make sure to move everything over to one side first. Okay, so what's different about 4 compared to 3?
They go the y is the positive.
The y is a positive, which means that we want to put the y first, then the x, and then the constant on the other side.
You can divide the leading coefficient out.
We could, remember, we're grouping, right? So the 4 and 24 are good, 9 and 90 are good,
Oh.
right? Because we're not taking GCF for the x's and the y's, they're gonna be different. More likely than not. We just need a GCS for the individual variables. Okay, so, but the important thing is that the y is squared, sorry, the y squared is positive, so that's gonna tell us which order to put our equation in. Okay, so now you're gonna go through your complete the square process. I'm sorry, GCF and then complete the square. So have you guys try it and I'll work through it at the same time that you guys work through it. Now, make sure that if you complete the square, that you're always doing a plus space. And no matter what the sign is, always put a plus space. And that has to be positive. All right, everybody good up to this point? Okay, b over 2 squared, 10 over 2 is 5, 5 squared is 25. Six over 2 is 3, 3 squared is 9, multiplied by -4. let's go ahead and fill this one out as well, because I do want to make sure that we're comfortable with the horizontal transverse axis versus the vertical transverse axis. So yeah, let's do number 4, filling everything in as well. Y is the positive one. You know, this is hyperbola that's going to open up and down. Okay. Center to upper corner, up to over 3. That's my slope. Up to over 3. Okay. Number 3, we'll just get to general form, and that'll be good. Oh, sorry, we'll get the standard form, and that'll be good. Okay. Number 3, you can tell this is a hyperbola. Your x squared and y squared have different signs. X squared is the positive one, so x squared first, then the y, and then the positive. You should read number 5, not 3. Is anybody still working on number 4?
The equation always subtraction.
I'm sorry?
Is the equation always gonna end up being subtraction?
If it's a hyperbola, yes. That's hyperbola, your x squared and y squared will always show different signs, which will always force a minus to show up between your x's, x and y's. Okay, I just wanted to get to the standard formula, standard equation. Any questions here? Okay, so let's look at page 25. This is really one of the last things that we need to do is look at series of information clues about the hyperbola, and we have to gather enough information to create the equation for the hyperbola, right? I have to find a way to gather the a, the b value, and the center somehow with the minimum information that they're providing. Right. Everybody good up to 5? Okay, you guys can put this on the top of the page. There's transverse axis and there's the conjugate axis. Okay? The transverse axis is going to connect from vertex to vertex. Your conjugate axis is going to connect from covertex to covertex. So maybe one way that I just thought of that could help you make that connection so you don't mix these up is there's a V in transverse. Maybe that helps with the fact that there's vertex and vertex there. And the conjugate starts with a C, covertex, covertex. Okay, so let's start with number 4 here. I'd like to just go ahead and use the graph to help me picture what this could look like. So the center is at 4, -2. That's my HK. A is 2, B is 3. Good, they gave us so much information here. And they say that the transverse axis is vertical, so that's going to help us decide which equation to use. Transverse axis is vertical, so do we want the y to come first or the x to come first? So y, yep, because transverse axis is vertical, means I want my y to dictate my a value. This is my transverse axis. Okay. So I'm going to write my formula and then fill in the rest. And we don't have to sketch more than what we need just to find. So the whole point of this is just to write the equation. So we don't have to. It says use the grid if it helps. We don't have to fill out the entire picture. Okay, number 5. The length of this transverse axis is 6 units. So we know vertex to vertex, that entire distance will be 6 units. The foci are at 3, 2, and -7, 2. So we know if we know the locations of our focal points, what can we figure out easily? The center, right? So your center is always between your foci, it's always between your co-vertices, and it's always between your vertices. Where's the center at?
You put it up.
Oh,
Your phone.
sorry, thank you. -7, 2. Okay, centers at -2, 2. Did you guys get that? So if I know the center and my focus, what information can I get out of that? Right, then we know the a value is somewhere here, but this is going to be distance here is the what? C value. Transverse axis units, so we know that from vertex to vertex, it'll be 6 units, which means that my a value must be what? 3, yeah. Right, we already know how it's going to look, right? We know it's going to be a horizontal because if my focus is to the left and to the right, I know my vertices must be to the left and to the right. Transverse axis will connect from vertex to vertex. I want the entire distance to be 6, and the center has to be in between that. So 1, 2, 3. Right vertex. Okay. Go through your formula to find your b value. horizontal transverse axis, we know what form we want this to look like. Our center. -2, 2. Okay, we'll finish up 2 more and then we can start our review tomorrow. Okay. Actually, there's one more thing that I want to do after this, but it'll be quick. Okay, go ahead and try number 6. But number 6 is telling us that the conjugate axis is 8 units. So what variable can we find from this information? B, yeah, because we know that code vertex to code vertex will be 8 units, and we can find the center and we can there find the B value. Everybody okay with 5? Hey, any questions with 6? Number 7, the center is at 0, 1. That's our HK. Focus is at 10, 1, and eccentricity is 5/3. So we know eccentricity is C over A, but it's the ratio, it's the relationship between C and A. It's not necessarily the C and A value. So it could be 5 being the C, the A being the 3. It could be 10/6. It could be, 15/9. So we just have to figure out which, just have to be careful that we don't lock into that 5/3. Because it may not be the exact A and C value. Let's see if we can find some clues so we can kind of narrow down here. So center is at 0, 1. One focal point is at 10, 1. So that's enough for us to know where my other focal point is, right? And what information is that going to give us?
10/6.
That's right. Yeah, that's our C value, right? Our C is actually locked in at 10. Now that we know the C is 10 and we know the ratio, we know, okay, it's got to be 6, right? So we're using the eccentricity to help us find that relationship so we can find A and C. Once we have A and C, we can use the equation to help us get to our B value. And we know this is a horizontal transverse axis because focus is going to be on the same plane as the vertex. So we know the X is going to be the one coming first. You can drop the 0 if you wanted to. Okay, everybody good? Okay, one last thing. This will be quick. Now the quiz is just over ellipsis and ellipsis and hyperbola, but we still need to be able to identify, given a general equation, which shape it is. Okay. So we know hyperbolas are easy to spot because your x squared and your y squared will be different signs. So which of these is obviously a hyperbola? D, right? 4y squared minus 4x squared, obviously different signs. We don't care what the coefficient is, but we just automatically know that we're dealing with hyperbola or D. Okay. Parabolas are also easy to spot because it's only one x squared and then the other is y. So there's only one variable that's squared. B, right? You see how there's an x squared, but then there's no y squared, right? Or it's y squared and no x squared. So not, both variables have, one variable has a squared, the other doesn't. So that should be easy to spot. Maybe the I don't think it's too difficult, but between circles and ellipses, your signs will both be the same. So signs are the same. Signs are the same. So what is it that's going to distinguish between circles and ellipses?
Oh, the circles both the same value.
That's right. Your circle will always be symmetrical. So your x squared and y squared will be the same signs and the same number. Ellipses will be the same signs, but different numbers. And here, D, I want to show you that it doesn't matter that my numbers are the same. As soon as I see that minus sign, I know it's going to be a hyperbola. So it could be 4 and 4, it could be 4 and 6, it could be 5 and 9. But the coefficients, if both the x squared and y squared are the same sign, then you can decide is it a circle or an ellipse. Same coefficients, a circle, different coefficients would be ellipse.
The quiz is only on like ellipses on hyperbola.
Right. But as far as the quiz goes, circles and parabolas will come into play just in terms of being able to identify.
Okay.
But you're not going to have to graph a circle or do anything with a parabola. All right, so we'll start our quiz review tomorrow. Let me get the phone.
Thank you.
Like maybe
I'm not gonna be here tomorrow, like go ahead and get the quiz review.
So, what you want is in your packet, you have to have that in where.
Okay.
And also, we're gonna do. I was like. Not even my son. And there it goes. I really enjoyed it, actually. There you go. No, I really enjoyed it. I'm